Hello, my name is Olubankole Aladesui Orangandade, and today I'm happy to present our poster titled TDP43 Mislocalization in C9orf72 and Sporadic ALS Spinal Motor Neurons Suggest Biphasic Nucleolar Stress. This work was inspired by recent findings that nucleolar stress occurs in C9 ALS FTD. However, until now, it was unknown as to whether or not this also occurs in sporadic ALS, and additionally, it is a mystery as to how pathological hallmarks such as TDP43 mislocalization and antisense RNA foci correlate with this phenomenon. In the present study, we examined spinal motor neurons from 11 control, 11 C9, and 11 sporadic ALS cases. We examined roughly between 10 to 40 neurons from each case. When we averaged the fibrillarian area from each of these cases, we found that nucleolar size was significantly reduced in C9 as well as sporadic ALS cases. In order to make sure these results were valid, we randomly sampled between 2 to 13 neurons from each of these cases, and on the left you see the comparison from control to C9, and on the right the comparison between control and sporadic ALS. We permutated this process 1,000 times and averaged the p-value. We found that a relatively small number of neurons, just 6, was enough to produce robust statistical significance. We also wanted to make sure our results were not skewed by gamma motor neurons or overall reduction of size in ALS. So we stained for estrogen-related receptor gamma, which is expressed in gamma but not alpha motor neurons. By doing this, we found that gamma motor neurons were up to 2,000 micrometers in size. Notice here that the size of alpha motor neurons in C9 and sporadic ALS is much smaller than those from control cases. When we examined nucleolar size in alpha motor neurons that were over 2,000 micrometers, we found that indeed nucleolar size was reduced in C9 ALS, however it was only slightly reduced in sporadic ALS, suggesting that the nucleolar size reduction, especially in sporadic ALS, strongly correlates with reduction of cytoplasmic size. Next, we wanted to see how nucleolar shrinkage correlated with markers of pathology, especially antisense RNA foci and TDP43 mislocalization. Previously, we had shown that antisense RNA foci, particularly their localization to nucleoli, correlates with TDP43 mislocalization. What we found next was quite surprising. Nucleolar size reduction occurs in neurons with or without these nucleolar antisense RNA foci. Similarly, nucleolar size is reduced in neurons with normal nuclear TDP43, as well as abnormal cytoplasmic TDP43 mislocalization. We wanted to see if additional markers of nucleolar stress occur in ALS. So next, we turn to laser capture microdissection data from sporadic ALS spinal motor neurons. We found that globally, mRNA encoding ribosomal protein subunits were upregulated in this dataset, and this includes mRNA encoding both large and small ribosomal protein subunits. Interestingly, gene ontology terms related to ribosomal biogenesis as well as protein translation are significantly enriched in sporadic ALS, suggesting that indeed nucleolar stress occurs in sporadic ALS. Our results suggest that biphasic nucleolar shrinkage is a characteristic of nucleolar stress and precedes pathological hallmarks such as RNA foci and TDP43 mislocalization. Importantly, nucleolar stress not only occurs in C9 ALS FTD, but is also a part of sporadic ALS.